Hello, I'm still in section 10.2, objective 2. I'm going to first of all review rational, irrational, and non-real numbers first before you do this example right here. Okay, so rational and irrational numbers. Let's start with that. A rational number is defined as anything that can be written as a fraction. So in decimal form, I'll just kind of write here, we typically think of it as a fraction. In decimal form, it either terminates or repeats. So I'll give you some examples of that. Okay, so what do I mean by that? Terminates means the decimal just stops. For example, 1/2, that's 0.5. Or 1/4 is 0.25. They just stop after a while. Repeats means the decimal keeps repeating. For example, 1/3 is 0.3 with a 3 repeating. That's also considered a rational number. Okay, so those are the rational numbers. The irrational numbers are the values in decimal form that either don't terminate or they don't repeat. Some examples of that would be any square root of a non-perfect square. For example, if I put the square root of, let's say, 5, if you were to plug that in your calculator, you're going to get some long irrational number. That decimal is not going to repeat or terminate. But if I put the square root of, let's say, 36, that comes out to be 6. That does terminate, so that would be a rational number. Some other examples of irrational numbers would be pi. You guys remember that? We just had pi day a short while ago. That's like 3.14, and it keeps going on from there. Or another one is e, which I don't know if you've seen that before, but that's approximately 2.7, and that keeps going from there. Okay, finally we have non-real numbers. Whenever we have a square root of a negative number, that's considered not real. For example, the square root of -3. That's not real. Okay, so now let's go back to our sheet. Okay, the first one is the square root of 25. The square root of 25 is 5. So that is a decimal that stops, that does terminate. So that'd be considered a rational number. The square root of 29. 29 is not a perfect square. If you plug that in a calculator, you get some really messy decimal. So that'd be irrational. The square root of 64, the opposite of it. The square root of 64 is 8, so this would be equal to -8. Again, that's a terminating value, a terminating decimal, so that would be considered another rational number. The next one, the inside part is negative. When you have a negative inside the radical, that is not real. That's actually what they call a complex solution, an imaginary unit, which we'll talk about a little bit later on. So that one is not real. And then find this last one, the negative is on the outside. So I'm going to take the negative square root of 300. The only problem is 300 is not a perfect square. So if you were to plug this into your calculator, again, you would get a messy decimal value that does not terminate or repeat. So that would be irrational. So it'd be like a negative, etc. decimal value. So that's irrational. Okay, so kind of going back again. So rational in decimal form either terminates or repeats. So that'd be a square root of a perfect square. Irrational would be a square root of a non-perfect square, and some other examples would be pi or e, which is used for exponential growth. And then non-real would be a square root of a negative number. So I'm going to stop here.